Unit 4, pages 135 to 138, Analytical and Graphical Connections between f of x, f prime of x, and f double prime of x, Part 2. In the previous video, we looked at f double prime of x and its connections, initially between f of x and f prime. Now we're going to synthesize that and use that information. So since the second derivative is the first derivative of f prime of x, right, the second derivative is the derivative of the derivative, then the same relationship that exists between f of x and f prime of x must exist between f prime and f double prime of x. With these relationships in mind, we're going to complete the following table. So if f double prime of x is equal to 0 or is undefined at x equals a, then f of x has a potential point of inflection. If f double prime of x is greater than 0, then f of x is concave up. And if f double prime of x is less than 0, then f of x is concave down. And if f double prime of x changes from either positive to negative or from negative to positive, then f of x has a point of inflection, which we can call PO. So now we're going to look at the relationship between f double prime of x and f prime of x. So if f double prime of x is 0 or is undefined at x equals a, then f prime of x has a potential max or min. Remember, the relationship between f double prime of x and f prime of x is the same relationship between f of x and f prime of x. So we're looking at the derivative of a function. It just so happens to be the derivative of a derivative. So if f double prime of x is greater than 0, then f prime is increasing. If f double prime of x is less than 0, then f prime is decreasing. And if f double prime changes from positive to negative, f prime has a relative max. And if f double prime changes from negative to positive, f prime has a relative min. Okay, so now we're going to consider the function f prime of x equals 2x minus x sine 2x on the open interval negative 5 to 5 to answer the following questions. So to do this problem, you want to first plug in that equation into your calculator and graph it to see what the graph looks like to kind of answer these questions. So the first question is, based on the graph of f prime of x, how many relative extrema does the graph of h of x have? Give a reason for your answer. Okay, so if we look at the graph of h prime of x, we'll notice that h prime of x on the interval from negative 5 to 5 only has 1 0 that changes from negative to positive. Okay, so since h prime of x has only 1 0 on the interval negative 5 to 5, h of x has one critical number. At that value of x, h prime of x changes from negative to positive. So h of x has a relative min. Question number 2, based on the graph of h prime of x, how many points of inflection does the graph of h of x have? Give a reason for your answer. So for us to look at h prime of x to determine point of inflection, we're going to need to look at, if we look at our table, right, we know that f of x will have a point of inflection when the second derivative changes from positive to negative or negative to positive, or when the derivative has a relative max or a relative min. So looking at our answer to part 1, we know that we only have, looking at our graph, we can see that we have 5 relative extrema, just looking at our graph. So the derivative h prime of x has 5 relative extrema on the interval -5 to 5. Therefore, h of x must have 5 points of inflection on that same interval. Okay. Now, for our final question, find the equation of h double prime of x and then graph it on your calculator. Explain why the graph of h double prime of x confirms your response to question 2 above. So h prime of x equal to 2x minus x times 2x. So h double prime of x is the derivative of that. So 2 minus, and then we have to use product rule. So 2 minus sine 2x plus x cosine 2x times 2, because sine 2x we would have to use chain rule. So when we simplify this all out, we get that h double prime of x equals to 2 minus sine 2x minus 2x cosine 2x. And when you graph this, you'll notice that h double prime of x has 5 zeros and changes signs at each of them. Therefore, h h of x has 5 points of inflection, as we stated in part 2. Okay, so the next 3 pages are basically going to be that you have a graph and it'll tell you if it's f of x, f prime of x, or f double prime of x. And what you're going to do is use that information from the graph to make conclusions about the 2 missing functions. So if I'm given f of x, I'm making conclusions about the derivative and the second derivative. If I'm given the derivative, I'm making conclusions about the original and the second derivative. If I'm given the second derivative, I'm making conclusions about the original and the derivative. Okay, so what we're going to do here is I'm actually not going to go through each and every one with you. What you're going to do is you're going to make the conclusions, and I'm just going to give you hints for how many conclusions you might be able to make and also what to look for in the graphs. So for the first graph, we're given the function f of x. We want to state all conclusions that can be made about its derivative and its second derivative and justify each of our conclusions. So if we're given the function of f of x, just by looking at it, we can identify extrema and we can identify the function type, right? So this function is a quartic function. The functions you're going to get on these 3 pages are all polynomials, so you can kind of identify what kind of function it's going to be. So this function is quartic because we know it has 1, 2 zeros, and this third zero bounces back, so that counts as 2 on its own. So that's 1, 2, 3, 4, 4 zeros. The other thing we can identify are points of inflection, because on polynomials, the points of inflections are halfway between maximums and minimums. So between a maximum and a minimum is a point of inflection. Between a maximum and a minimum is a point of inflection. Okay, so using that information, what conclusions can be made for the derivative and for the second derivative? I'll give you a hint. The first derivative, we can make approximately 10 conclusions. And for the second derivative, we can make approximately 4. Okay. Okay. So on page 137, we're given the graph of the function f prime of x. We want to state all the conclusions that can be made about the original function f of x and the second derivative. Okay, so looking at f prime of x, we know that its sign analysis for f prime of x will tell us increasing and decreasing for f of x. But also, we know that maximums and minimums of f prime of x will tell us some information about our second derivative. So, using this information, you can make about 8 conclusions for f of x, and you can make about 4 conclusions for f double prime of x. Remembering that this is a polynomial, and we can identify the function type as well, just by looking at the zeros. Right? We have 1, 2, 3 zeros, so this function type is cubic. And for our last page, page 138, we're given the graph of the function f double prime of x and want to state conclusions for the graph of f of x and f prime of x. So the sign analysis for f double prime of x tells us concavity of f of x, right? But we can also identify a few things for the derivative. And we can also identify the function type. So this function has 1, 0, and then at this 0, we bounce back, so that counts as 2. So we have 3 zeros, so this function is cubic. So from the second derivative, we can make approximately 4 conclusions for the original function and 4 conclusions for the derivative function. Okay, so what I want you to do with those 3 pages is actually try to come up with as many conclusions as you can for all 3 of these graphs. And tomorrow we will actually look at all of the conclusions that can be made from the graph. You now have all the information that you need and can complete all the homework problems in the homework packet.